Okay, so here's a video showing you graphically how to solve logarithmic equations. So remember the graphing calculator, depending on the model that you have, some of the older ones can only type in base 10 logarithms, right? Or logs that have base e, which we call natural logarithms. So like something that looks like this, right? Or like this, right? This is a natural log and its base is e. Here, this is a logarithm, and notice there is no base written. So when there is no base, you assume that it's base 10. So these are called common logarithms, and they are easily typed into all calculators. But something like this, log base 4, like I said, depending on the calculator, you may have to use change of base here. And so I'm going to go ahead and show you that. So to basically change the base to base 10 or base e, I'm going to go ahead and do base 10, something that you can easily type into the calculator. We would use the change of base, which would be log base 10 of x divided by log base 10 of 4. Okay, so if you don't have, this should be 2, negative 2. If you don't have a calculator where you can type in base 4 or something besides base 10 and e, you're going to have to use change of base here, which is what this would be, okay? I will show you, some calculators have the option if you press the math button and you go over, you stay here and you go all the way down. Some of the calculators have this option under A, log base. You press enter, you can actually type in whatever base you want. So that would be base 4 here. And then of what would the argument be? X, okay? So we're trying to solve this equation. So the left side would be log base 4 of x. So that would be y1. And y2 would be negative 2. We're going to try to find the intersection of this log equation and this horizontal line. Okay, so if you do not have this option on your calculator and you can't type it in that way, if you have an older version of the calculator, you would have to type it in like this, log of x, parentheses, close it, divided by log base 10 of 4. So you would have to type in this using the change of base formula. But I'm going to go ahead and leave it how I have it up there and leave log base 4 of x. So I'm going to go ahead and graph this. And so I'm going to go ahead and change my window settings to the standard window settings. So negative 10 to positive 10 for my x-axis. And my y-axis, I'm going to do negative 10 to positive 10 as well. You can change your scales or leave it like that. And so this, remember, keeps going like this, and it's going to get really close to that y-axis. So there is an intersection point. It's just really hard to see. So let's try to zoom in a little bit. So instead of negative 10 to 10, I'm going to do negative 2 to positive 2. And I'm going to do a scale of 1. And then I'm going to do negative 2 to positive 2 on my y-axis, and I'm going to also do a y scale of 1 as well. See if this helps. And so it's a little bit clearer. Let's change my y-axis, go down a little bit. So instead of negative 2, let's do negative 4 on the y-min. And so there it's a little bit clearer. You probably didn't need to do that to make it clear. You probably could have found the intersection point, but I just like to be able to see it really well. And so now I'm going to press second, trace, and I'm going to go to option 5. And I'm going to press, I'm going to get close to that intersection point, which is somewhere right here. Let's see where my cursor is. So it's right here. I'm going to move it close to that intersection point, press enter. Second curve, it's already close to the intersection point, press enter. And press enter again. Okay, so here you get an intersection. Your x value is 0.0625. Okay, so if the My Math Lab wants a fraction, you just have to type in that decimal and then press Math and go to option 1, convert it to a fraction. And so the answer here is 1/16. Okay. Remember, you have to check logarithms. You want to make sure that when you plug the number back in, that whatever the argument is, so in this case, the argument is x, that it doesn't result in a negative argument. And in this case, 1/16 is positive. So we're good here, okay? So looking here, we're going to go ahead and solve this graphically. We have 4 plus 3 times log of x equals 10. So this is going to be my y1 and then my y2. So going here, I'm going to go ahead and graph. This is log base 10. Notice there's no base written, so it's log base 10. Everyone should have no problems typing this in. There should be no need to use change of base here. So 4 plus 3 times log of x. And then on the second one, we're going to put 10 in. And we're going to graph it. Okay, so I'm just going to go back to my standard window settings, zoom, and then option 6. Okay, well, I don't see the line y equals 10 is up here, so I need to change, and I see that they are not intersecting, so I'm actually going to change my y-axis and my x-axis. So I'm going to change my, my y scale, so instead of 10, let's do 20. And then my x max, I'm going to bump that up to like 20 as well, just to make sure I include that intersection point. And I still don't have it. Okay, you see it's getting close here, so I need to bump my x scale up again, my x max. So let's do 45. See if that gets us the intersection point. Still doesn't. Let's try it again. Let's do 75. Go up a good bit. And it's getting closer. You could try to do it at this point. I'm just not 100% sure if they intersect, so I'm going to go ahead and do it one more time. I'm going to do like 150. And I'm going to do my scale here by 50. Okay, I think that we see the intersection point. It's just really hard to tell because this graph is slowly increasing. So I'm going to go ahead and try it. We're going to press second, trace, go to option 5. And then, so we're on the first curve. I'm going to move my cursor over to the right just to get a little closer to what looks like the intersection point. Press enter. Second curve, press enter again, and press enter one more time. And so our x value here is 100. Once again, you want to check and make sure that if you plug that 100 in, you want to make sure that the argument, whatever the argument is, whatever you're taking the log of, doesn't result in a negative argument, and it doesn't in this case. You can actually plug this into calculator to check if this results in a true statement, and it will, but you can actually check these answers, whether it's a decimal or an integer whole number. You can actually check the answers for these problems. Okay, so if I would do 4 plus 3 log of 100, oops, too many logs there, log of 100, we should get 10, and we do. So that is a true statement. That is a solution. And so the last one we have here is 5 plus natural log of x equals 10. So remember, when it's a natural logarithm, the base here is actually e, which is a number. And so here, your calculator has a natural log button. And so we're going to go ahead and use the intersection method. So that's going to be 5 plus the natural log of x. So that is going to be a graph of a logarithm. And then we're going to see where those graphs intersect. So here we're going to put 8. So I'm going to go ahead and graph it. And the window settings from the last problem actually work here. We can clearly see the intersection point where this horizontal line intersects with the graph of the logarithmic equation. And so no work on the window settings here. You can go straight to the intersect. And then I'm going to move my cursor a little bit closer. And I'm going to say, that's close enough. I'm going to press enter on the first curve, enter on the second curve, and then enter one more time. And so here you end up with x equals 20.086. Okay. So the only problem with using the graphing calculator sometimes is here, we get it, the calculator is going to give us an approximation. Okay. Sometimes on my math lab, they want an exact answer. This is a rounded answer. It's an approximation. So that's the only issue you can come into using the graphing calculator, is that they're going to sometimes say, I want the exact answer. So if they say that, you may have to solve it algebraically. But a lot of times the graphing calculator is very useful for solving these equations. It makes it a lot quicker, and you kind of skip over some of the properties. But sometimes you may have to solve it algebraically. So like this one, if the problem said, give me an exact answer, then you would need to actually solve it algebraically. So that is it for solving logarithmic equations using the TI graphing calculator.